Hello and welcome to PreCalc. Today is Friday, October 16th, and our topic for today is inverse functions. Great, let's dive right in. First, let's call this example 1. Awesome. Okay, we're going to focus on this example 1 first. You should definitely pause as much as you need to get a nice organized table here. So today we're finding inverse functions. We're first going to go over our process for finding an inverse function. Our first step is change f of x to y. So we have y equals 3, and nothing else changes. Okay. Our step 2, this is actually the definition of an inverse function, is we want to switch x and y. So we're going to keep everything else the same and just switch our x and y. Y becomes x becomes y, nothing else changes. And to finally find our inverse, we are going to solve for y. So first thing I want to do is add this 1 to both sides. So x plus 1. We're going to divide out our 3. The opposite of a square is a square root. So I'm going to take the square root of each side to get rid of that square. So I've got, and the last thing we'll do is take away the 4. Great, and this is our inverse function. And then our final step here is we write y inverse as it looks like f to the power of -1, but it means inverse. Oops, I forgot my square root here, and here we have square root there. So my answer is square root x plus 1 over 3 minus 4 off to the side. Okay, let's try another one. Okay, it wants us to find the inverse of 2x cubed plus 3. Alright, let's change f of x to y. We're going to switch x and y now. Everything else stays the same, so that cubed stays right where it was. Now we want to solve for y. I'm going to rewrite the function so that y is on the left-hand side. Okay, take away 3. So I have 2y cubed equals x minus 3. We're going to divide out the 2. And I've got y cubed x minus 3 over 2. Just like the opposite of squared is square root, the opposite of cubed is cube root. So I'm going to take the cube root of each side, and I get that y is the cube root of x minus 3 over 2. Let's write it in proper notation. We're going to say the inverse should be a -1. Inverse of x is the cube root of x minus 3 over 2. Alright, let's consider another example. Feel free to pause whenever you need. Make sure you're writing down these original problems. Okay, we have f of x, and it says find the inverse. Okay, same steps. I'm going to switch f of x to y. I'm going to switch x and y. I like having y on the left-hand side, so I'm just going to rewrite it like this. Okay, take away 2. So y over 4 is x minus 2. We're going to multiply both sides by 4. These will cancel, and we get y equals 4 times x minus 2. Y is 4x minus 8, and let's write this in our proper notation. The inverse function is 4x minus 8. Great. Okay, now we have another example. We're still going to be finding inverses, but now we are going to compare and contrast how the domain and range and the graphs are affected. So, here, let's find this inverse really quick. I'm going to switch f of x to y. Switch x and y. That should be y plus 4. Square root side. Square root of x equals y plus 4. Take away 4, and we have y is the square root of x minus 4. Let's write this in proper notation. Great. So it wants us to graph both of these. Let's do f of x in black first. So x plus 4, my vertex is at negative 4, and it's squared, so I have a parabola shape. Reminder that this negative 4 comes from setting x plus 4 equal to 0, and then we get x equals negative 4. Okay, our next one is the square root of x minus 4. That minus 4 is a vertical shift down, and then it has our square root shape. Okay, so what's the domain of our f of x? It has all the x values to the left and to the right, so this domain is negative infinity to infinity. Our range, however, its lowest value is 0, and then it has everything above 0, so our range is 0 to infinity. For the inverse, our domain is 0 to infinity also, because it has all x values in this direction. So notice that the range of the original is the domain of the inverse. And then the range of our inverse is everything from negative 4 up. Alright, we're going to try one last example like this. Okay. Same deal as the last one. First, let's find our inverse. Y equals root x minus 3. Flip x to y. To get rid of a square root, we square. So x squared equals y minus 3. Add the 3, and y is x squared plus 3. Let's do proper notation. Equals x squared plus 3. Great. Let's graph these now. Okay, for this one, I need my vertex. So I'm going to set that equal to 0. So that's 3 comma 0, because there's a 0 because there's no number off to the side there. So I'm at 3, and it has our square root shape. Okay. This vertex here is 0 comma 3, because there's nothing with the x, and the plus 3 represents a vertical shift. So this guy looks like this. Okay. The domain of f of x of the original, well, it has access to everything 3 and onward. So 3 to infinity. The range, its lowest y value is 0, And then it looks like this flattens out, but this curve actually keeps going up just at a slow rate. So it has access to everything 0 to infinity. For our inverse, the red curve, it has all the negative x, all the positive x. So its domain is negative infinity to infinity. And the range is everything from 3 and up. So our range is 3 to infinity. Notice how the domain of the original became the range of the inverse. Alright guys, that's everything for today. Thanks.